Hey, I'm Melissa.
And I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand the chemistry of your everyday life. Quarantine edition.
Quarantine bonus edition.
Bonus edition quarantine. Double bonus, double quarantine.
What? Not double. Well, we did do 2 double episodes this week.
Yes, and
this month.
You and I are both quarantined, so double quarantine separately. So
okay, that's fair. That's absolutely fair. Okay, before you start asking me questions,
okay,
I had a lot of feedback on the helium episodes from my brother and brother-in-law.
Oh, interesting.
Yeah, I know. It was so weird. They called me on the same day to give me their thoughts.
And just curious, do they have any right to do that, or?
I mean, I don't know who they think they are.
That's what I'm saying.
I'm just kidding. So my brother, who took a physics of sound class, said that there's more to the story than just density, that air compressibility plays into it, and also those waves are called compressional waves, the specific sound waves. So that was 2 things I didn't know. And I would like to go look up and read a physics of sound book, but that won't happen until after my semester ends. So that's that. He also wanted to make sure we knew, and we kind of mentioned that vocal cords were out of our scope, but that vocal cords are 2 things vibrating together, which is different than the drum head going up and down by itself, but still interesting and makes the same kind of waves.
Right.
Now, my brother-in-law, he's the boat captain. He told me that scuba divers use helium when they're diving below recreational depths to mix in with their oxygen and their nitrogen, because oxygen can be toxic at certain levels, I think under certain pressures. And nitrogen can bring on this narcosis. It's like a narcotic. You basically get drunk when you're down there.
Holy.
And so they will cut it with some helium, which is non-narcotic, doesn't have that same kind of thing. And you can watch scuba divers come up with that helium voice, or underwater you can kind of tell they've got the helium voice on YouTube videos. And I went and looked it up, and those are both real. So I thought that was funny and thought I would pass it along from my brothers, from the men in the fam.
That's so funny. That's crazy.
I know. Isn't that weird that it elicited such a brotherly response?
Yeah. Yeah, seriously.
So I thought that was fun.
That's awesome. Dang, thanks, guys.
Yeah, thanks, brothers.
Okay, first question is from Jake K. He says, related to episode 33 about thermoses keeping coffee cold, how do manufacturers create that vacuum of nothing?
Awesome, Jake. This is a good question, and I tried to watch YouTube videos to show the manufacturing process, and the vacuum part seemed to always get skipped. So the only thing I can think is that they do the majority of the welding and have one portion that they can hook up to a vacuum tube and then seal it off, almost like when you blow up an air mattress and then close it real quick.
Oh.
I think it's like that. That's my best guess. I don't know, and I couldn't find an answer that was satisfactory to me. So
Interesting.
Yeah, but so there are things that pump down. They call them vacuum pumps. So they basically pump out all the molecules to leave a vacuum behind. So that's how you create a vacuum. You have a pump that, I think it just creates this negative pressure so things come out. But I don't really know the chemistry behind vacuums very well. But I know that you can do that. So I have used vacuum pumps a lot in my lab. So I'd assume they would have some kind of a vacuum setup, and then they can seal off that last little open part of the bottle at the last minute.
What if they just had like a vacuum chamber where they put it together in the first place?
I think that would be expensive and hard to do. And it didn't seem like that from the manufacturing videos.
Right. I was thinking
it seemed like they were just making them.
Got it. I was thinking like, well, that would be kind of easier, at least from the outsider perspective of like, It's just already in a vacuum. So put it together and then boom. As long as it's like...
I think it would be hard to have a vacuum chamber, but I don't actually know.
Interesting. Good question.
Anyway, that is a good question, and it does get the mind working. And also I wanted to say on that topic, our friend Shael sent us a video of her coffee cup with ice in it.
Mm-hmm.
And I tried to rewatch the video, but Instagram deleted it after a certain amount of time.
Oh,
so
yeah.
It was a video of her coffee cup, and she said about 30 minutes or so, I put this in with my coffee and my iced coffee, and it's been sitting here at, 90 degrees Celsius or whatever, or Fahrenheit. 90 degrees Celsius would be very hot. 90 degrees Fahrenheit for a while, and the ice hasn't melted, and I just don't know how because it didn't have a lid on it. And she asked our opinion for how that would work. And I think I have two thoughts. One, it's possible that there's a very good insulation that not only has no molecules in there, but then also has some stuff that reflects the heat or does other things besides just have no molecules in there to keep it from even escaping out the top. Could have a very good vacuum seal where there's absolutely nothing transferring the energy, but even then with the top open, if it was sitting in the shade, like maybe under the car console, my guess would be that, well, I know this happens. You have to put in a closed off container. The whole body of water has to reach the temperature of the degree above the ice cube. So I think it's possible that it just wasn't getting enough heat because of where it was sitting in the shade. I think it was in the shade based on the video with the strong insulation, and it was pretty far down there, like it was a tall looking cup.
Yeah.
So it just wasn't getting enough heat for all of the little bit of coffee at the bottom and the ice cubes to heat up and melt. That's my theory.
And I don't have any theories, but it's similar to my setup. I never put a lid on my vacuum mugs. I use them for hot and cold stuff. And I just have similar findings about different weather conditions and temperatures that they seem to work really well still. So that's without knowing exactly how that works. I've found the same thing, whether it's cold outside and I have hot coffee or hot outside and I have cold coffee with ice. It just is like, seems like a night and day difference from a regular mug or regular cup to a vacuum cup.
Nice.
Yeah, I hate lids.
I don't feel like I have a lot of experience with that, and I feel neutral about lids. So
you're like a little bit lukewarm about lids.
Oh no. Yeah, I'm lukewarm about lids.
Okay, this next question is from Liz S. She says, we recently talked about micelles in chemistry class, and micelles are found all around us in daily life, from soaps to micelle water, skincare products. That can maybe be a good topic.
So, Liz, that is a good topic. And actually, I thought this was a good opportunity to say, and I think SD mentioned something along the same lines, another listener, SD, who's also a chemist. But I'm not sure that we ever actually said that when you have soap, a grease molecule, and it's got all the polar parts on the outside and the non-polar parts on the inside around the grease molecule, that is called a micelle. And I have no idea how micelle water skin care products work. So I would love to look into that. And one of the things I'm hoping for this summer is to get an opportunity to ask some experts in other areas of chemistry questions about stuff like that.
Interesting. I didn't even think about that, but I know that my wife has some of that stuff, micelle water, and it does seem really weird. Like it looks like just water, but it like gets a lot of makeup off or something like that. It's kind of
interesting.
Crazy. Yeah.
I've never used micelle water, but I've heard of it.
It tastes really
so
good.
That is that is a good question, Liz, and I'm glad you pointed out, because I've been meaning to say for a while that is called a micelle, and I don't think I ever said that in either of our soap episodes, so I've been remiss.
Oh, interesting. Yeah. I think I would have thought about the micelle water thing earlier if I had realized that too. If I'd known that's what it was. This next question is from Kirdo F. Sorry if I'm mispronouncing your name. He says, from the apples episode, can quinones react inside your body. Is that melanin the same as the melanin? Melanin is part of our skin.
Okay, so I looked quickly up to see if quinones react inside your body, and they do, for sure. There's reactions with quinones inside your body, but I don't know if the quinones we ingest go into some of those reactions with cells or not. So I don't have a complete answer. But the melanin on your skin question, I think, is going to take a whole episode because I don't know. I've heard that the melanin in our skin is what makes it darker or lighter, but I don't actually know what happens when your skin tans. So I'm excited to dig into that one a little bit more. I feel like I've got a lot of half answers on this week's episode.
Yeah. A lot of them that will make really good topics for future episodes.
Yeah, but I wanted to kind of shine a light on those because I think sometimes I just skip over those in favor of ones that have more satisfying answers, but I think it's still worth it.
Yeah, absolutely. This next one's from Shay L. And this is kind of a summary because you sent us a voice message. Do purple carrots have beta carotene? How do we see them with different colors, and are they nutritionally different?
This is such a good question. My roommate just brought home a bunch of carrots that was white, orange, and purple. So I had a great visual. But the answer, Shael, is purple carrots actually do have beta carotene in them. They have a lot of beta carotene, but they also have another pigment that makes them that color. And they are nutritionally different from the other pigment because there's more antioxidants in purple carrots. From that dark color, remember, has a lot of conjugation, which is how antioxidants work. There's also red carrots, which have the same molecule as tomatoes. I believe it's lycopene. And white carrots, and there's this cool website from the USDA, and we'll link to it in our references, where they talk about the different nutritional values of carrots. And white carrots actually don't have the benefits of beta carotene or any other pigments, so they're just mostly good for fiber, whereas purple carrots have more antioxidants and beta carotene and all kinds of other things. So they are absorbing light differently because they have different pigments in them, and that's why we see them as different colors.
Interesting.
I know. I never even thought about that. But they do say to have multiple colors in your food because a lot of times different pigments will offer different nutritional things. So
yeah,
not like different color Skittles, but bright, colorful fruits.
Right.
Veggies, that kind of thing.
Yeah. Skittles don't count.
No, not colorful candy.
So we also got a lot of people submitting. We asked people to tell us why they used to think the sky was blue before knowing how. They may have found out their own way, or found out from the episode we did about why the sky's blue. So a lot of people have sent in their theories about why the sky was blue when they were young or before they knew why. And so I thought it would be cool to read through some of these.
I'm very excited about this.
Should we just alternate them?
Yeah, I think so.
Okay. Why don't you go first?
Grace S. said, I always thought that this is embarrassing, that it was blue because it was a reflection of the sea, or maybe it was the other way around. Either way, it blew my mind. I don't think that's embarrassing, Grace. I think that's good.
It blew her mind.
Oh, BLUE.
The next one is from Vianette G, and she thought it was just because of water in the clouds. So, learned oh yeah, it rains, I guess, and water's in the clouds, so maybe that's why the sky's blue. That makes sense.
We also need to talk about why clouds are white.
Oh, dang. Yeah, we do.
Tori M. said, I have always heard the sky was blue because of the atmosphere, which I realize is vague, but it was enough for me. I figured something in the stuff up there made it blue, similar to how water is blue in large quantities like the ocean, but not coming out of my faucet at home.
So she had she was fine for a while not knowing the details, but just being like, okay, I guess that makes sense.
Right. Tori is great at replying and sending in topics. I think I'm going to do one of her topics in the next few weeks, so way to go, Tori.
Oh, yeah, she's awesome. And then she also told us what her husband's theory was, and it's pretty great. he said the Earth is actually a donut shape, and the reason why the sky is blue is because you can see the ocean above you.
I hope that was a joke. I think that was a screenshot from Reddit.
Yeah, it was. I think then there was like a photo of seeing the Earth be kind of donut shaped or whatever. But my immediate thought was like, only some people would actually see the ocean above them. Like they had to be on the inside of the donut. Everybody else on other parts of the donut would just be seeing
outer space. 100%.
So I like that theory a lot. It's certainly not true, but it sounds like a more delicious theory than some. Because donut shaped, you can't not think of donuts. So
one of the other things that we haven't talked about is why water is clear coming out of your faucet, but blue in big quantities.
Yeah, I wonder about that.
I have a theory, but I actually haven't looked into it. I can tell you what it is if you want. Or do you want it to be a surprise? You're deciding for all the listeners, so.
Well, do you think we'd actually do an episode about it?
I think we could.
I'd love to hear the full episode, so you could share your theory beginning and then tell us the real thing, I guess, if you want.
Okay, I'll harken back to this one.
Yeah.
Okay, and if it's not good enough for a whole episode, then I'll bring it up in next month's bonus episode.
Perfect. I like that. That's perfect.
Great. Well, I think that's all the questions we have. I tried to keep this week short and sweet because you already got a bonus episode hearing us talk about books.
Oh, yeah, that's right. Kind of
on Jim's other podcast.
Yeah, kind of an unofficial bonus.
An unofficial bonus. Before we wrap things up, I wanted to do a shout out to Carol, the English coach. She teaches English and did a little video where she used our episode about toothpaste making orange juice taste bad to help teach English. And I thought that was so fun and exciting. And she has a podcast, and I've really just been enjoying a lot. It's very soothing, and I think it is really helpful. I've learned some things. I didn't know what a phrasal verb was until I started following her podcast. So I really enjoyed listening to Carol's The English Coach's podcast, and I just wanted to say thanks to her for doing an episode about what we did. So she's teaching people chemistry and English together, which I think is so cool.
Yeah, she seems really cool.
Go check her out. She's Carol, the English Coach on Instagram, and we definitely follow her.
We also want to give a shout out to people who have donated to our Ko-Fi in the last month since we've updated you guys on that. So Todd H, Eris F, Brenlin B, and Joseph S. Thank y'all so much for donating to our Ko-Fi and helping keep our show going. We really appreciate any amount that you guys give. And so I just wanted to shout out those people. Thanks for listening and for helping keep it going. It's also a good opportunity to update you guys on the costs of making this show. And it's a good problem to have, but our listenership continues to increase each month, which means we're getting very close to the threshold of our hosting fees, where once we exceed a certain download limit per month, we'll have to go to the next tier of membership with them, which will cost more. It's a natural thing to happen, but that does mean that our hosting fees are about to more than double. We just want to be transparent with you guys about those kinds of needs and let you know that any amount you guys donate through our Ko-Fi is very, very helpful. And we're about to be in a situation where we actually have more financial needs to keep the show going than we used to have. So again, it's a good natural problem to have. But if everyone who listens to our podcast each week gave $3 or the cost of a cup of coffee, we'd cover those costs very quickly. And so I just wanted to ask, if you haven't already considered giving the cost of a cup of coffee, just know that'd be really, really helpful and help us meet those needs quickly. At the same time, more than just keeping our show going, it helps other people around the world learn about chemistry. That's the whole point of the podcast. Not really just to keep a hobby going that Melissa and I have, but really to teach other people. So every bit counts, and we thank you so much to people who've already given. We're so thankful for you guys, and we're also just really thankful that you guys listen at all. So appreciate y'all.
Yes, we're so thankful. Whatever you decide to do, we absolutely could not do this podcast without you. So thank you so much for listening and supporting and sharing. This has been a dream come true for Jam and I.
Yeah, absolutely.
This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson, and we'd like to give a special thanks to E. Robinson, who reviewed this episode.